You see, I was born in the first half of last century, and I was brought up by parents who were socialists. And one of the books that they used to read to me when I was a little boy had to do with Robin Hood, the man who robbed from the rich and gave to the poor. And therefore, the Brits became my favorite nation. I admired them an awful lot. But that came to an end very swiftly in the early 60s when the Brits invaded our fishing limits. And I don't think that the Brits realized how serious this was. And I am now going to present to you some genetic data that support my contention that they could hardly have violated our rights more than by invading our fishing limits. And it comes from our study of the genetics or perception of smell. And we found a variant in the gene that makes the trace amine-associated receptor type 5, which actually has a very significant impact on your ability to smell fish. So if you have this variant, the probability that you will be anosmic when it comes to the smell, particularly of rotten fish, is about, with an odds ratio, about 3. And it increases the probability that you will report the smell of fish as being pleasant. And actually, it's interesting because in Iceland, we have lived mostly on fish in all stages of fermentation for 1,000 years. And actually, you remember this old saying, you are what you eat? And actually, frequently in the morning when I look at myself in the mirror, I ask the question, Kari, are you getting old or are you turning into a fish? And actually, when you look at the frequency of this allele, it is 2.2% in Iceland, 1.7% in Sweden, 1.2% in the UK Biobank, and 0.2% in Africans. So obviously, we have been sort of turning into a fish slowly, and we are insensitive to our own smell. But my love for the English was restored recently with the arrival of the UK Biobank, which is the biggest gift ever given to science by any nation and eventually to healthcare. And therefore, hereby, I know you have been waiting for my forgiveness for a long time, but hereby, you are forgiven for invading your fishing limits. So this should be a good day for you. But then comes the question, why should the UK Biobank be whole genome sequenced? So I am asked to express an opinion. I have been working on sort of biobank-related research for a quarter of a century. I'm not asked to tell you about the results of that, but an opinion on whether we should or not whole genome sequence the UK Biobank. And the reason it wasn't done in the beginning, the reason that they started with the whole exome sequencing, which has been done brilliantly by Regeneron, and I am, as usually, very proud of the way in which they do things, but it is much cheaper. The sequencing throughput is tenfold greater with the whole exome than whole genome. The instrument cost is less, but the hands-on time for sample preparation is somewhat greater. The non-coding part of the genome is about 98% of the genome, and actually, we shouldn't call what is lost by whole exome sequencing. We should rather have it what is not gained by whole exome sequencing, because what we gained by it is an awful lot. And just working with the 50,000 that are already available has been very generous to us. But there is a fraction of exons that are not captured by the whole exome sequencing kits, and these rich regions are not amplified efficiently with PCR, and that applies particularly to first exons and the promoters. And there is a capture of allele bias. And the more the haplotype is similar to the reference, the more easily or efficiently is it captured, and structural variations are called less efficiently in the whole exome sequencing. And this is just giving a couple of examples of how the coverage is different. And in the chattel gene, this is definitely because of DC richness in a part of the gene. And actually, there is a recent examination of the loss of, or absence or loss of exons through the whole exome sequencing in about 7,000 of the genes. There is a probe covering every exon, but in 12 to 13,000, there is a loss on average about 2.5 exons. This is not a large number of exons, but this is still something that needs to be captured. And we have at Decode several discoveries that we have recently made where the exon of importance was not captured by whole exome sequencing, and we have some papers out for review describing that. In whole exome sequencing data, about half of the reads overlapping a variant have a wild-type allele, and half of them have a mutated allele. And the capture-based whole exome sequencing leads to systematic bias in this allelic balance. And actually, the allelic balance is one of the most important filters in whole genome sequencing for private mutations, but it is much less so in whole exome sequencing because of the bias. And the more different the haplotype is from the reference in the region of the capture probe, the more is the allelic balance biased. Most of the common disease associations are with non-coding sequence variations. We have an awful lot of things left to capture there. And the non-coding variants with large effect have been found, but they are more challenging because of the numbers and difficulties with our notation. But if you only have good data on the exome sequence, it will mean that you're going to lose a lot of causative variants, and actually associations may be falsely ascribed to coding variants because of linkage disequilibrium with non-coding variants. And there are several papers recently out demonstrating the importance of having the non-coding sequence, and I'm not going to go into the details of those. Even in diseases like autism, which we are most often looking at as rare variant diseases, the rare variant coding mutation diseases, there is an enormous importance of the non-coding sequence. And the reason, one of the fundamental reasons that we need to sequence the UK Biobank is that it will become the largest reference in the world, particularly important for clinical sequencing. And the rich phenotype data will allow us to do all kinds of things, and keep in mind that although the coding variants are most likely to be associated with the disease, there are strong sequence variant annotations of coding of regulatory sequences that will also be enriched for associations. And the enrichment of associations gives direct assessment of biological relevance of the annotations. But having said that, it is important to realize that a few years from now, we will see that the reason to sequence the UK Biobank is totally different from the one that we are predicting today, or at least in my experience, having worked on a population research like this for a quarter of a century, is that at least my guess, my a priori assumptions, my hypothesis, turn out to be almost always wrong, and the data humiliate me. But anyway, we need to whole genome sequence the UK Biobank because because they cover better the coding regions. They allow us to understand associations better. They allow us to use develop understanding of non-coding sequences much better. And actually, the enormous amount of phenotypic data already in existence in the UK Biobank, and the expectation of gathering even more, means that it is our duty to make sure that we have gathered as much data on diversity in the sequence as possible. And I want to end by emphasizing again the generosity that is reflected in the way in which the UK Biobank is run, providing everyone access. I mean, you guys have managed to do something that the Americans have never been able to do. There is not a single data resource in America that is as available in as generous of a manner as the UK Biobank. So congratulations, guys. It was well done.